Welcome to part 2 of Unit 2, Lesson 11, Finding Intersections. These videos can only be 15 minutes at the most, so sometimes these videos will be broken down into 2 parts. Okay, now, for the third one, let's look at our points of intersection. So basically, we're going to set these equal to one another. But first thing we have to do is that we have to multiply. So when you go to multiply binomials or polynomials, please draw your distribution arrows so that you know to multiply. Okay, so running through the math. X times x gives us x squared. X times negative 4 is negative 4x. 7 times x is plus 7x. 7 times negative 4 is negative 28. That gives us x squared plus 3x minus 28 is equal to 2x times x is 2x squared. 2x times 4 is negative 8x plus 5x minus 20, giving us 2x squared minus 3x minus 20. Put everything over on the left side. So we're going to subtract 2x squared from both sides. We're going to add 3x to both sides. We're going to add 20 to both sides. Add the 2 polynomials gives me negative 1 x squared plus 6x minus 8 equal to 0. I'm going to multiply the whole equation by negative 1 because I need my leading coefficient to be positive. I get x squared minus 6x, minus 6x plus 8 equal to 0. Okay, so going back to the factors of 8. 1 and 8 and 2 and 4. 2 and 4 add to 6. 1 and 8 add to 9. Subtract. We get 7 and 2. 6 is my middle term. This tells me the larger term is negative. This tells me they both had the same sign. So I get x minus 4 times x minus 2. Set equal to 0. And let's finish up on the next page. So we left off with x minus 4 and x minus 2 equal to 0. X minus 4 equal to 0. Separately from x minus 2 equal to 0. Add 2, add 2, add 4, add 4. X equals 4. X equals 2. So now what I'm going to do, okay, now that I found 4, I stuck 4 in for m into polynomial m and polynomial n. But since 4 minus 4 is 0, one of my points of intersections is 4, 0. 4, 0 works for both m and n at 4. So they have the same point of intersection. So that's one point of intersection. Now let's see if the 2 works for both. So doing my math, sticking 2 into m and n, I get 2m. When m is 2, the output is negative 18. That's negative 18. So that's positive 2, negative 18. And when I stick 2 into n in the purple one, I get the same thing. I get negative 18. So because they're the same point, I have 2 points of intersection. 4, 0 and positive 2, negative 18. Okay, now let's look at this polynomial here. So again, when you multiply polynomials, draw your distribution arrows to make sure you remember to distribute. It just builds a good habit. X times x is x squared. X times negative 8 is negative 8x. 1 times x is plus 1x. 1 times negative 8 is negative 8. Set that equal to x squared minus 4x plus 2x minus 8. I'll get x squared minus 7x minus 8 is equal to x squared minus 2x minus 8. Add the polynomial to both sides. I get 0 on this side. Minus x squared plus 2x plus 8, giving me negative 5x equals 0. Divide by 5 on both sides. Negative 5, I'm sorry. And x equals to 0. So I only get one answer. So that must mean I have one point of intersection. You can always graph these and find the points of intersection. So the first thing I have to do is stick 0 back into P and into Q. So P at 0 is 0 plus 1 and 0 minus 8, giving me 1 times negative 8, giving me negative 8. So the point is 0 comma negative 8. And let's see if we get the same thing for Q. So Q, I get 0 plus 2 and 0 minus 4, which gives me 2 times negative 4, which is negative 8. So 0 comma negative 8 is the same point, which means 0 comma negative 8 is my point of intersection. And you can always check these by graphing them on the calculator. Okay, so now we've done all that. Let's show you how to graph these on the calculator. So what you're going to do is put this, hit the y equals button, put this one into y1, put this one into y2. We do not worry about the left side. We only put the right side into the calculator. So you hit the y equals button at the top. Then what you're going to do is hit second graph. Second graph brings up the table of values. What you want to look for is the x column is first, y1, and then y2. And it's going to look like this. What you want to look for is where both y values are the same. When both y values are the same, that is a point of intersection. When both y values are the same. Now, if you just go back and hit graph, you will see that one of them goes like this and one of them goes like this. And the point of intersection is right there at 0, negative 8. That's going to show up on your graph. I should probably, let me do this in a different color because that looks like all the same. So let's say this one is this one. So this one would be Q and negative 1 and positive 8. Oh, whatever. Let's just call this one P. I probably got them backwards. It's probably, the one on the left is probably Q and the one on the right is probably P, but whatever. So that's how easy it is to graph. And that's why graphing makes things so much easier. Okay, let's look at this problem. Graphing to find points of intersection. So we have two polynomials. One a polynomial, which you're going to put into, you're going to hit the y equals button. You're going to put the purple one into y1. You're going to put this one into y2. This is a constant. Now, a constant is going to make a straight line, but that's okay. Now, the problem is you will not be able to see the point of intersection. So if you want to see the point of intersection, you're going to have to hit the window button. The window button is at the top, is right next to y equals at the very top. You're going to have to change y max to about 5,700, at least 5,700. Now this is going to make the top of the window very, very high so that you can see the point of intersection. And basically what you'll see is the window will be like this. You'll see a curve. You're only going to see part of the x cubed, and you're going to see a line like this, and they're going to intersect at the very top. You might have to take your x max out to about 15 or 20. You might want to change your x max too, because you might not be able to see it in the window. Okay, from there, hit the graph button. When you hit the graph button, after you change the window so that you can see the graph, your graph should look something like that. Now, to find the point of intersection with a calculator is very easy. All you have to do is hit second graph to bring up the table of values. Now you'll scroll down a little bit. Your X column will be here, your Y1 and your Y2 column. And then you'll have numbers. You keep scrolling down till where you see 5640 is equal to 5640. And what you should see is 10. So the point 10, comma 5640 is the point of intersection because both Y value equal at when X is 10, both the Y values are the same. And that's all you have to do on a calculator. Put the functions in the Y1 and Y2, hit second graph, and scroll through the X's. You scroll up with the up arrow and down with the down arrow until you see where both Y's have the same value.